Hi everyone, my name is Sarah. I am from Caltech, specifically the Caltech Latino Association. Yeah, so basically, I want to thank everyone for coming. I hope you guys have been enjoying the STEM night. And also thank you to Isabella and Charlotte for doing a wonderful job organizing the event. So first off, who am I? I'm Sarah, I'm from Caltech. I am majoring in mechanical engineering and I am a junior. So I've been here for about 2 years. I'm currently taking a year off to do an internship. So I'm actually doing real life engineering stuff, which is really exciting for me. And also, what is CLASES? So we'll see the acronym there, and you're probably a little bit confused. It stands for the Caltech Latino Association of Students in Engineering and Sciences. Basically, we are a student club at Caltech affiliated with the Center for Diversity. And as part of that, we host a lot of cool events that are social events. So sometimes we get together and eat lots of food together that's really tasty. And other times we do sort of community service events. So like this, for example, we give talks to people about how cool science is and all that. And then also we do professional development events. So again, also kind of a scary word. But basically that means that when we sort of have ideas for where we want to work and have a job and have a career, so basically help everyone with all that and sort of introduce them on learning how to talk to people and learning how to sell themselves. So that's a little bit about me and my club, and I'm currently the president of it. So I'm very passionate about the work that we're doing, and I think that we're definitely going to be pretty fun and exciting. So first off, I'm going to describe what is fluid mechanics. Very scary sounding word, but I promise it's not all that scary. The definition of a fluid is anything that's a liquid or a gas. So a liquid is anything like juice or water, anything of that kind. And so for example, if you pour it and it makes, basically anything you can spill is considered a fluid. And then anything that you can, anything that's a gas. So if you had any level of chemistry classes, basically that includes things like the air, stuff that you breathe in, stuff like that. So those are both considered fluids, and that's what the study of fluid mechanics is. And what is mechanics? Mechanics is basically the study of how these things move. So basically when it's fluid mechanics is we're basically just studying how fluids, so water or air, moves. So why do we care about it? Initially we were like, who cares about, just pouring water into a glass or something like that? Yeah, basically kind of like the states of matter. So it's 2 of the 3 or 4 states of matter. Yeah, so basically why do we care about it? It actually has a lot of applications because initially you're thinking, it doesn't really matter if I'm just pouring water or anything. However, it actually has a lot of applications in real life engineering things. So for example, in a car, if you're driving a car, you can use fluids to sort of understand how it's flowing around it. So for example, if you're going really fast, you might all of a sudden notice that you're not going as fast as you would like it to be. That's because of something called drag. Basically, the fluids are just pushing back against your car, making it move a little bit slower than it would. And then also, it's a really big deal for things like aviation, so planes. If you've ever taken a flight, you're probably wondering how the heck did this massive metal thing get launched into the sky? And that's because of fluids. So not only all the studying and research we do helps us understand this. And then also, it's useful for things like the ocean or clouds. So if you ever wonder, why waves work or, why the clouds are in a certain way, fluid mechanics also helps describe all that. And so now that we know what fluids are and also why we care about it, let's kind of have some fun with them. So I'm going to pop this link in the chat so you guys can check it out yourselves. Yeah, so I'm going to pop this link in the chat really quickly. Definitely click on it and have some fun. Basically, what you can do is if you have your mouse, you can just click on the mouse and you can drag, and you basically create these little disruptions in the fluid. So the way you can think about it is like if you've ever like stuck your finger in water or something, or like a pond, and all of a sudden the water starts rushing around your finger. It's kind of similar to that. So the black is basically when nothing is really happening, everything is still. However, if you click and drag, you basically are disrupting the flow and disrupting what system's already there. And so you get a lot of cool swirly patterns, lots of stuff like that. And a bunch of different things can affect it with like, you know, crazy names like pressure or vorticity. But you can basically play around with these little options here, and you can sort of see how things change. So vorticity is basically, you know, how fast things rotate. So that will adjust the way that you can actually see it. So definitely recommend like playing with it yourself. It's a lot of fun, lots of different colors. So definitely just like take some time and enjoy all that. I'm probably just going to be playing around with different things like density diffusion or velocity diffusion and just sort of see how things change. So definitely a lot of fun. And so one thing you'll also notice is you'll see a lot of these like little, I guess, tiny swirls. They actually have a cute name. They're called eddies, kind of like the name Eddie, but not actually. So that's kind of a fun term you can use if you ever want to impress your friends. You can say, oh, I know what that's called. Yeah, basically just have a lot of fun playing around. Fluids are really cool. You can basically do a lot of really fun experiments at home if you'd like. And, you know, basically all this is doing is showing you what happens if you move an actual fluid in real life, which is really exciting.
How did they make this kind of program? Because this is cool.
Yeah, so what makes fluids so complicated, oh, thank you for the question, but what makes fluids so complicated is a lot of really complicated math surrounding it. So what happens is the way they're able to sort of show what the different colors are is it basically solve these really hard equations, and then it'll tell you what it should look like. So for example, when I'm moving my mouse across the screen and I'm creating a lot of, you know, basically disruption, what it's doing is it's saying that at each point, the flow looks like it's going to be moving in like a circular direction. So basically all they're doing is they're solving a lot of math equations and then they're showing it to us. Why do the swirls look the same as the storm in Jupiter? Good question. It's because it is like the storm in Jupiter. The reason why it looks that way is because that's just happens to be the way the fluids flow. So also you'll ever notice if you see any photos taken from space of the Earth, for example, you'll notice that the clouds look pretty scary. Or if you see like a hurricane or something and you see that sort of swirling pattern, that's because that's just the way the air is flowing, and the clouds are the way you can actually see it. So definitely you can like see fluids in all sorts of different applications, and that's what makes them really cool in my opinion.
Excuse me. Just to tell, uh, if I put density diffusion all the way to 0, it'll make a blank white screen until I put it back into normal.
Oh, wild. Yeah, I don't know why that is. Hmm. I think I actually understand that. So basically the way that what density is, it's basically like how thick something is. So for example, water has like a low density, but like a table has a high density. That's why you can't like push it or anything. So what happens is when you put this density diffusion really low, it becomes really hard for it to move around. So that's why it stays in this disrupted state for a very long time. So that's probably why you see the white is because if you make the density diffusion really low, it'll basically kind of get stuck for a little bit longer. And then Debbie is asking, why does it look like an asteroid hitting Earth? Um, Honestly, that's probably just because like if an asteroid hits the Earth, basically the pieces of it will like fly through the air. And since it's going through the air, it'll follow rules of fluid mechanics.
Okay. Another thing I noticed is when it's paused, I can still put it, but it doesn't do anything. It makes the big white screen and it goes out pretty quickly if I put density very high after I uncheck it. I really like that feature.
Yeah, it's really cool. You can see how basically different aspects of like just basically what we're changing, you're changing numbers in the equations that I told you about. So you can see how much that actually impacts everything. So I'm glad you really like the simulation. I think it's pretty fun.
Yes, there's also a mobile app I see.
Yeah, so if you definitely like want to check it out after this, you can probably like download the mobile app, or you can just like on your parents' computer, you can ask if you can basically play around with this tool a little bit longer and make cool looking shapes.
Just to tell, I know I actually have a school Chromebook, so I can download it on there.
Yeah, so if anyone has like a school Chromebook as well, or any other like school issued devices, definitely worth it if you just want to learn more about how things move and how the world works.
But I do not really want to press any of those buttons, like Twitter and everything. It just opens that application which I do not want to touch. Okay, if I press random splats, it puts me random splats. I like it.
Yeah, I'm really glad that you like it.
But don't put random splats while paused for too much times. If not, it'll put that white screen.
Does anyone else have any more questions? Or I guess ideas they want to throw out there?
What about eddies?
Yeah, what about eddies?
Yeah, eddies, and how are they formed?
Oh yeah, that's a really, really good question. So basically what happens is if you have, let me think of a way to describe this that makes sense.
We completely now change the background color in capture settings.
Yeah, so the way that eddies work is basically, so the easiest way to create them is actually just by creating a straight line. But you can obviously do a bunch of different ways to do that as well. But the way it works is it ends up basically, all it is that the fluid is kind of getting slowed down. So what you see is on the edges, you'll see that the fluid, at least, let me see if I can change some settings here to make it a little bit easier to see. And slow it down. Yeah, so basically what you end up saying is that the I guess like the flow that's outside of the space that you're looking at is stopped, and all of a sudden you're moving something through it. So what happens is it kind of gets a little bit confused and it doesn't really know where to go. So what happens is it kind of gets slowed down and creates that sort of circular pattern that you notice. So basically the stuff on the edges, you can tell that it's actually kind of moving slower than the center of the swirl. So that's essentially why eddies end up creating that sort of circular pattern. That's a really good question.
Are eddies like a whirlpool?
Yeah, they're exactly like a whirlpool. That's exactly what they are.
Excuse me?
Yeah.
I saw that right now when you make intersecting lines and then you make it like a T, it will change the amount, like you know how the water, if you make a straight line it goes straight. Now if you make a horizontal line, it'll change the water's pattern to the horizontal line.
Yeah, that's very cool. That's a good thing to notice.
I don't see Game
You don't see the game?
in the chat.
Oh, in the chat? Okay, I'll send it again. That way you can have fun with it. There you go.
Mama, think about it. This one's really funny. Excuse me, these look like nebulas.
Yeah, they do. It works the same in space. So basically, whenever things are like moving around,
Ooh.
it looks like. Yeah, isn't that like really awesome? That basically fluids look a lot like a bunch of different things, which is really exciting. So essentially, whenever you study something as simple as that, it's not only you studying water, it's not only you studying air, it's you studying, space as well, because you can apply the same things to it. Anyone else have any questions?
It's really cool.
Yeah.
On something, it kind of looks like a jellyfish.
Yeah, it actually does look like a jellyfish. I thought that was really cute. I think it's pretty similar to like kind of how jellyfish move.
Yeah, what is happening?
You want to yes, yes, yes.
Anyone else have any questions?
Do you want to try it, guys?
Yes.
For a little bit more about me, I actually did research the past 2 summers in fluids. And so what was really cool is I was actually able to make this happen in real life, which I thought was really exciting. So it's definitely something where even though it's like very colorful and a lot of fun to play with online, it also is something that's equally as fun to do in real life. So definitely like next time, the next chance you get, if you ever go to a river and it's safe to do so, you can definitely like stick your hand in, or you can move it around. And so you can see that this pattern is also reflected in the real world.
Is there other WebGL stuff?
I'm sure there is. This is one that the research group I worked with really enjoyed. So this is one that we've been playing around with. But if you want to find cool stuff online, definitely search up fluid mechanics and then probably put about how old you are. And then you can see lots of cool things. I did notice that they had like a few like videos online. They had a few like lessons for people in elementary school as well. So you can definitely check it out.
You could make this happen in real life by like throwing a pebble or a rock at the water.
Yeah, exactly. So every time you do that, you can actually see it, in motion. So it's kind of like.
When the airplane lands, I saw the smoke. Things were going round and round.
Yeah, that's definitely also because when a plane is landing, it's going really, really, really fast. So it's basically having to slow down. And so that's why the air around it gets like all funky looking. So since the airplane burns fuel, you'll oftentimes see like a little bit of smoke or something coming out of the engine, but that's like called exhaust. And that's basically what you end up seeing whenever your plane lands. It's basically the air around it is going fast, but it wants to actually be going slow.
This is awesome. Thank you.
Yeah, I'm glad you guys all enjoyed it. So basically we're at 6:35, so it's coming to the end of our session. So definitely go back to the central documents. That way you can go to your next session.
Thank you.
I hope that you guys all enjoyed and learned about food. So definitely have a lot of fun, you guys, and definitely play with this website in your spare time if you'd like.
Thank you so much. I had so much fun. Bye.
Thank you so much. That was the coolest app I ever had in my time. I ever experienced.
Thank you.
Thank you so much. This was amazing.
Thank you.
I want to do more.
Oh, it's so big.
That was so cool.
I